Let's talk about gravity. There are few learning points about gravity. Remember, gravity is a universal attractive force between all matters. The strength of this force depends on the mass and the distance. Also, it only acts on the objects with the masses. Newton's law of gravity. It states that every point mass attracts other point mass by a force that is acting along the line intersecting the both points. The Newton's law of gravity, it states or tells us that force of gravity is directly proportional to the product of the masses, and it is inversely proportional to the square of the distance between them. So therefore, as you can see in front of you, if you combine equation 1 and 2, we come up with an equation for the gravitational force which is equal to Gm1 times m2 over r squared. In this equation, F stands for the gravitational force, G stands for the gravitational constant, and then m definitely for the masses, and r is the distance between the center of the two objects, as you can see in the diagram in front of you. So therefore, we conclude that the greater the mass, the greater the force. So therefore, the closer the objects are and the greater the masses of the objects are, the greater will be their gravitational force, which is pulling them together. For example, if you just notice that our Earth has a very good gravitational pull. Why? Because this Earth has a huge mass. Okay, now, in physics, and especially in the A-level physics, there are a few questions coming about gravitational field lines. So what are these gravitational field lines? These are the lines which is actually giving us the visual representation of the gravitational field around a mass. So these gravitational field lines, there are a few things that you should remember about this one. These field lines, they emanate, that means they come out from the center, they radiate outwards, and they never intersect each other. The more the closer you are to the source, the stronger is the force. And as you move further away, or as the distance increases, this gravitational force, it becomes a little bit weaker. Earth is a huge mass, so near the surface of the Earth, our gravitational force is nearly uniform. That is why this is called as the radial field. I want to show you this radial field in the diagram here for you in figure 3 and figure 4. You can see here that the gravitational force is represented by the gravitational field lines, which actually shows you a very uniform field line. And as you can see here on the diagram figure 4, that Earth has some gravitational field lines coming towards it. So this is actually representation of the gravitational radial field. Okay, then let's very interesting thing to note is about the falling objects. As the object falls down, the speed decreases. What is the reason behind that? Although it should increase, because there is a gravitational pull. The reason is that as the object falls down, there is an increase of the air resistance, which actually stops the speed of the falling object. And one more interesting fact that you might know is about the moon. So the moon has a mass which is smaller than the mass of the Earth. So therefore, the gravitational pull on the moon is much weaker as compared to the Earth. So in other words, since weight is equal to mg, so our weight on the moon will be less as compared to the Earth.
Tutoring and resources, log on to www.physicsonlinetuition.com.